right, Engine Performance Expo viewers, we're back. It's me and Ed again. So, we talked a bit about this engine we're building, the boosted LS with the Pro Charger on it. And we want to make some power, and make big power, you need a good foundation. Of course, the foundation for that is the block that's sitting here in the home. Now, to get to this point, a lot of work's already been done.
Yes,
so Ed, tell them a little bit about what we've already done to the block to get it to this point.
Okay. Well, first of all, we're starting off with a Dart block, so we have a very good foundation there. Dart makes a tremendous product.
Iron block too.
Iron block.
It's an iron block LS, not an aluminum block. So makes big power, got a lot of strength.
Got a lot of strength. So honestly, as most people know, the heart of the engine is the main line. So one of the first things we want to do is even though the Dart stuff is just perfect, it's really good stuff, we wanted to ensure, so we put it on our F69A over here behind me, and what we did is we line boarded to make sure that all the mains were within 2/10 and straight in alignment to make sure that the crank rotates with very, very, very little resistance and isn't binding anywhere, so we're not wearing bearings out prematurely or putting more load on one main than we are another.
Right, because we're going to put a whole lot of load in the crankshaft with that boost.
Yes, sir.
So we don't want it to be kind of wampus to begin with.
No, we're going to make some serious power out of this motor.
All right.
So that was the first thing we did, and then once we did that, then what we wanted to do is we wanted to put it into the machine and bore the cylinders 90 degrees apart and straight, perpendicular to the crankshaft center line, and we did all of that on our F69A, and then the next thing we wanted to do was lifter board. So what we're going to do here is as I was saying, is we're going to make sure that these lifter boards are in the exact location.
Right.
Lifters being on the center line of the camshaft is absolutely critical to making horsepower.
Yeah.
And so we want to make sure that the lifter bores are at the right angle to be dead on center line of the camshaft, and also located over the lobe correctly.
So we're getting our geometry right.
Getting the geometry right.
All right, so we got a great part from Dart to begin with, but we've just fine-tuned that geometry to make it right. Another thing too is, as we mentioned in the very first video about this engine build, this isn't going to be just a one-time done deal. We want to go in the future, turn a lot of RPM, so making sure all of those things are right and bushed, key part of being able to do that next level RPM in the future with this engine. So we're doing these pieces now because it lives for us forever.
Right.
You don't have to go back and fix it later, get it right the first time, then you have to go back and fix it later. So, okay, so we've done the line boring, we've done the cylinder bore location, and we've done lifter bushing install. So now it's the fun part.
Well, we forgot one thing. We also forgot deck height.
Ooh, so really important deck height.
So we wanted to set our deck height. So we've set our deck height on this, and
deck height's done.
Yep.
Everything's ready to go. So now we actually have it in the home. And we're ready to use our Profilometer, which is my favorite tool. And we're going to get some surface finish. But talk a little bit about the geometry of what we're doing here as well.
Yep, absolutely. That's a huge part of this build, and a huge part of any performance engine success is bore geometry. Not only bore finish, but bore geometry.
Straight and round.
Straight and round. And one of the biggest misnomers in this industry is that I can take a dial bore gauge, and I don't care whose brand it is, and I can check it, and I'm going to check it 90 degrees to the crankshaft, and then I'm going to turn it to where I'm parallel to the crankshaft. And if you're distorting the bore because of pressure, or because of stones glazing, or because you have a weak cylinder there,
sure,
and guys are going to go, well, that's out of round. That's not necessarily true. That is not out of roundness. That is difference in size, but you can't check roundness with a 2-point contact gauge. It's impossible.
Right.
The only way to truly check roundness is with a pat gauge or an Incometer.
Right.
Okay, that's when you...
They're kind of expensive too, so
yeah.
don't have those around my backpack.
No, typically I've heard estimates 150, north of 150. So.
Right.
So it's not something most guys are going to have in the shop. So what we've done at Rattler is we did a bunch of experimenting with different hone heads and the amount of abrasives in the hone heads, and we found the optimum one, and that's you can always get better with more abrasives on a hone head. However, there's a law of diminishing returns.
Yep, makes sense.
And so the 6-stone hone head seems to be that happy medium to where we get the most bang for our buck, and we don't go overkill with having to buy 10 or 12 abrasives at a time.
Okay,
and get a much smaller diameter range.
Right. So one analogy I like to use, talking about bore geometry and how straight and round it is with a dial bore gauge, is if you had a slinky, you could measure it and it would still be right in every direction, but you could offset it like this and that would still measure right.
Excellent analogy.
But it's nowhere near straight or round.
But it's right.
Well, I guess it's round, but just not straight.
Yep.
But anyway, so the next part of beyond the board geometry, in this case, which is going to be dictated by the hone head.
Yes.
Next thing we do is surface finish. Now, with this engine, again, looking ahead, we want to give it a little more valley than we would normally do for, say, just a gasoline pump gas engine for the street, because who knows? We might get crazy. Ben Strader, his dyno, well, we can't say what kind of fuel we might throw in it. So we want to have a little more valley, plus we're going to put a lot of boost to it in the future, so we're going to go ahead and future-proof it now and go ahead and do that. So as part of this process, Ed, talk to him about how we get to the valley. Right? We talk about valley all the time, and it's important to have valley, but you really can't add valley when you're plateauing, can you?
No, you cannot. You have to determine your valley during the roughing operation. Without that, you'll never get the valley you're looking for. I get customers all the time that, for instance, want to put a 400 grit diamond in and then plateau.
Go to size.
Yeah, and go to size and then plateau it, and they're like, well, I can't get my RVK values. You won't.
Yeah, you can't get there from here.
You'll never get there. And the rule of thumb is, and I tell guys all the time, you have to have one of those profilometers. You have to have one in today's world if you're going to truly do a proper job plateauing.
Exactly.
And so what you'll do is you'll select a roughing diamond. It could be, we've got customers that are running an 80 grit to get the RVK
for some of them,
and some of those big boosted diesel stuff.
Right now we've got, a 170, 240?
Yes, sir. Yes,
Explain what that means, why there's the two different numbers.
Yep, so typically what it is diamonds, it's an industry standard, and there's a sieve that like sand particles pass through, and it's diamond abrasive.
All right.
And so you can get as small as a 220 grit, it's 200 grit, 200 grit, and as large as a 170 grit, and that's why they have those dual numbers.
Okay.
Now, when you get into the fine finishing abrasives, at anything above 400, they just use a nominal number.
Got it. Okay.
But that's why you have that dual number. Some companies just put one number on it, either the high number or the low number.
Got it.
We've always included both, just so people know what you're getting.
That's the spread. Okay.
But it is a industry standard.
Right. So that's really this is a spread of what the abrasive is. Okay. Yep. Really cool to know that. All right. So I am not the hone operator expert. I'm going to get out of the way. We're going to let Embry get in here and let Embry and Ed do their thing on the hone.
Let me, if many of you haven't met Embry, this is Embry from CNC Blockworks. He actually owns the CNC Blockwork company, and so he's doing all the lower end stuff while Mr. Straub works his magic on cylinder heads and camshafts. So Embry's been in this business for how many years now?
Since I was a kid.
Since you were a kid. How long ago was that? No, let's not do that.
No.
Embry and I are the same age, so I don't want him to give that information up. But he's been involved in the industry all his life, raced many different forms of racing and many different classes in drag racing, so tremendous amount of knowledge and expertise, and knows his way around this equipment. So we're going to let Embry do the operating, and I'm going to ask him some questions, and I'm going to do some talking also. So we have roughly about 2 thousandths left in these bores, and we're going to hone those out, as Blake and I had talked, with a 170 200 grit diamond, and that diamond should give us enough RVK to, after we plateau, we're still going to be in that probably 45 to 55, 60 RVK range. And so it's important when you rough one of these cylinders, before you ever decide to plateau and before you ever get to size, is to check that RVK number. So if I have 3 thousandths to take out of this cylinder, we might hone a thousandths or a thousandths and a half out of the cylinder and check our RVK. And if for instance, we're wanting 45 to 55, I need to have RVK numbers probably in the 65, 75 or higher range. And that way, as I plateau, those RVK numbers are going to come down. And so I can control that. I'd rather have more RVK, and it'll allow me to spend more time with the 600 grit diamonds, CBNs, and bring that RVK down. Now, one of the misconceptions is, well, if I spend more time with that 600 grit, my RPK, which is the peak count, will continue to fall, and that's not true. After just a few strokes, you've established your RPK. It's not going to change by more than maybe a point or two. So we're able to spend more time in there and play with or bring our RVK into spec. And that's why we want to go with a rougher diamond initially and have a little room to play than to try to use too fine a diamond and not have enough RVK to start with. No, you're really talking about microns. We're talking about 40 millionths or 2.5 microns in a tenth. So really minute. We've already honed some of the material out of this block. So we'll go ahead and grab our profilometer and do a check on our RVKs to make sure that we have a high enough RVK count. And then once we do, we'll go back in and just hone to size. And then we'll go in with our 600 grit CBNs and plateau the cylinders. And by the way, we're using an SG210 Mitutoyo, and I'm a walking advertisement for these things. These are an absolute necessary tool in order to do this properly. And I have found no one that can sell these things as inexpensively as Total Seal can. And the cool thing about it is they'll set it up for you. It'll all, there are parameters in these machines, and you can vary those. And you want to make sure that you're using the proper parameters to make sure that what you're seeing out of this particular instrument is correct. And Total Seal will set all of that stuff up for you and ship you one ready to go. So in this particular one, our RVKs are in the 50 range, low 50 in that one, and we might check another spot just to see where we're at. And here we're at our high 50s and low 60s also, so we're right where we need to be. So we're going to go ahead with the honing process. With these profilometers, I have a lot of customers now that record the data. They build a motor and there's a spec sheet there, and it gives you that RPK, RVK, and RK values. Embry, why don't you go ahead and fire this critter up and we'll explain just a little bit about what's going on here.
Like I had said, we already took a little bit out of initial just so that we could come with a common number between all the cylinders and be able to get a reading of the RPK, RVKs. We've got about a little over 2,000 left, and the machine's already set for that.
So that first stroke you saw was actually the machine checking to make sure that there was no interference in the bore. If it would have hit a main bearing web, or you would have had a bunch of taper in the cylinder, or there'd have been maybe you mistakenly left a piston oiler in, it would have sensed that and stopped the machine before it broke the tooling or the stones or the abrasives or anything like that. So it does that on each cylinder. Coming up, that we're honing it in this particular instance at a 30% roughing load, and it's also showing us the straightness of the cylinder. If the cylinder begins to get off from a taper standpoint, being it big at the top or big at the bottom, whichever it may be, the machine will auto-correct for you. So it literally is a walk-away machine.
This program is set up that when the machine gets down to 4/10 of a thousand, then it takes it from a 30% load on the stone down to a 20% load on the stone.
And I don't know if we mentioned this, but we machined this block one time, and we've decided to go a little bit larger. We were at 4/125, and now we're going to 4/155 on this board. More horsepower. Cubic inches, more horsepower. So we want want 41 degrees crosshatch angle. All you do is set it at 41 degrees. The machine will stroke at the proper speed to give you that 41 degree crosshatch angle from the bottom of the cylinder to the top of the cylinder. Very, very, very consistent.
One of the things I've noticed with it, and I always test and check, the cylinder next to it is 78 degrees. The cylinder that just got finished is 78 degrees. So you don't have the distortion that you have with stone type machines, which I love that part.
Yeah, the water-based coolants really do make a difference, don't they, in cooling the cylinders?
Yes, they do. It's unbelievable.
I tell customers all the time, there's really no cool down effect with a water-based coolant. Your cylinders are going to stay room temperature or water temperature from cylinder to cylinder to cylinder. So you don't have that, wait an hour or 2 hours and then go back in and touch it another 3/10 or 4/10 or 5/10, depending on how hot the cylinder got.
And we had a process before with the other style homes that we would skip the cylinder and work it back and forth just to be able to equalize the heat, build it, and keep it straighter that way. But with this, you go from cylinder to cylinder to cylinder, and there's no distortion.
We're going to start that second cylinder. The machine feeds out to the cylinder wall, double checks, make sure it's not going to hit any obstructions, and then begins the honing process again. So we were talking a little bit about, I've been doing this for 30 years, and this is the way I've always done it, and I don't need that profilometer, and I don't need to change my surface finishes, and again, I ask the question, are you running the same style of ring and the same thickness of ring that you run 30 years ago? And the answer is absolutely, positively no, you are not. And, then you ask, well, are you the same operating temperatures and the same horsepower loads? And you absolutely are not. And we can go into what about the motor oils? And Blake is an absolute expert in motor oils. And it used to be you run 2050 racing oil, and now these guys in Pro Stock are running zero weight oils. So the oil isn't going to adhere to the cylinder wall as well with a standard old 280 grit finish as it will with a Plateau finish. So these are all critical factors in today's high performance engines. And that's all we're trying to do is give you the end user a product that will stand the loads, the new technology, seal the motor up, make a bunch of horsepower, and be trouble free. So one of the other things we keep harping on in this segment is bore geometry. Okay? And so we can own a block and round it as straight as possible. And then we bolt the cylinder head on there, and the bore is no longer round. Another super critical point in machining a race engine block is to make sure you've got a torque plate on it. And it replicates the cylinder head where it'll distort the bore when you're honing it round. Now, once you take that cylinder head or that torque plate off, it may not be round any longer. But we hope that once you bolt the cylinder head back on the machine or on the block, you've got a round cylinder to start with. So again, it's just these little, what is it? How do you make 10 extra horsepower? 1 horsepower at a time. So those are some of those issues that we talk about. And we can go even further in when you start talking about torque to yield bolts and torque values and things like that. Where I see guys that run Molly bolts or Molly studs, and when they're torquing this on there, they don't use the Molly lube. They use motor oil. Motor oil does not have the same coefficient of friction that ARP lube does, and so you're using more torque to tighten that bolt, and therefore the clamp load will be different than when you use your ARP lube or whatever lube you would prefer to use. But I guess my point would be is whatever you determine you want to use, be consistent with that. You know, use your bolts, put the same lube on them when you're putting your cart plate on as you would when you're putting your cylinder head on. It's just all these little steps that make a difference.
So Ed was mentioning oil, so he drugged me on the set here to talk about oil a little bit. So as the machine runs in the background here, hopefully you can hear me pretty good. The idea of oil has changed a lot in the last 15, 20 years. Synthetic oils have definitely changed the friction characteristics. So back to torpedo bolts, that same friction changing things there also changes with the ring friction. And rings do need friction to break in. And like Ed mentioned, they are pre-lap. So now break-in oil is something that you can really look into to help that last little bit of ring seal. Is something that doesn't have friction modifiers. That's actually a higher friction oil that allows the ring and the cylinder wall to finish mating. Because at Total Seal, we've already pre-lapped those rings to get it as close to broken in as possible. So we're going through this honing process, going through it, plateauing it and all that to try to get it as close to broken in as possible. So the idea is you do all those things, you do it right, the right chemistry, boom, it breaks in right away, so you get maximum ring seal, which is maximum engine performance and longevity from day one, so that you're getting the most power out of the engine and you're going to get the most useful life out of the engine. That's the goal. Right? We're going through all these steps that you didn't have to go through in the past. Think about how much longer engines live today than they did in the past.
That's right.
That's the reason why. You think about it, those old engines with their big old giant 564, 316 rings, they didn't last very long. And when you did have to hold them out, you had to take out a lot of stock because it was really uneven because it wore the engines. Today's rings, way smaller, and they last a lot longer. So different material, different thicknesses, different surface finishes, different chemistry. We're utilizing technology to make things better. Throw away your Nokia brick phone, get you an iPhone, and the engine equivalent of that, better pistons, better rings, better honing technology. That's how you step into the modern age. So I could go on for hours about this.
Speaking of that, so there, being in this business for 47, 48 years, you get all these guys, and there's some wives' tales out there too.
Oh yeah.
There's all of these little nuances, and I get guys that constantly tell me, I'll only break rings in with transmission fluid, or I'll squirt WD-40 in the cylinder. Oh yeah. Rings in. Talk a little bit about the damage that they do by doing that sort of thing in today's rings.
Well, there was a point in time when some of those things made sense. ATF isn't what it was 20 years ago.
Right.
Dexmerk, old school, universal light fluid. Well, now you've got Dexron 6 and things like that are very different, have a different coefficient of friction, different chemistry. So in the old days when you had chrome rings and things like that, yeah, maybe there was some wisdom to that to help break in that ring. I mean, just a little thing is chrome ring. So a hard chrome ring is a dip-plated product, which means it's not going to be even thickness. So in the old days, guess what? We really were breaking in the rings. Sure. Because the ring wasn't really round.
Right.
So you needed a rougher finish. So you needed poor lubrication properties in the oil to be able to make that possible. Initially, not long term. That's not what it is now. So if you got an old school chrome ring, maybe there's some wisdom in that still.
Okay.
If you got a modern PVD chrome nitride ring, you don't need that. The moly rings, they don't need that. So it's all about application. That's the one thing that I learned in 15 years of doing tribology is, guess what? There isn't a single right answer for everything. Other than application always dictates chemistry and process. So define the application, then the chemistry, the process will follow from that. And what we're showing you here today is for a modern engine with the steel rings, what's the right way to get the most out of it. If you wanted to do a different video, a different segment, maybe one year on old school chrome rings and an old cast block, I guess we could do that. But I think most likely what people figure is you're going to run a 280 finish in it, and you're going to throw in some straight 30 non-detergent, and you're going to run it in for 30 minutes, hope the cam doesn't break while you're doing it, right? Maybe throw a little bit of ZDP in there. Make sure you should do that. Because you really just put BR30 in there and be good. But you treat it different. Why? The application is different. Application always dictates chemistry, and in this case, it dictates process as well.
So which should we use now on today's modern rings? Like, what should you use as a break-in lubricant?
All right, I'm biased because I did formulate BR30 at Driven as part of the Gibbs program. It also works. It is my go-to oil. Okay. I know that what makes it unique isn't the brand. What makes it unique is that it is a non-friction modified oil. That's the real key. It has enough anti-wear additives in it to make sure everything in there is wearing in, or breaking in, not wearing in dramatically. You're not scuffing, galling, scoring anything in the engine. You're just allowing the natural amount of wear to occur, but we're using chemistry to help make that happen faster. So it's not the old days of 3,000 miles. Hey, we're doing this in 30 minutes now, because we're using chemistry to assist that process of those surfaces mating. Like I said, we're not wearing them in, we're just letting them mate properly. And it's that having anti-wear additives without having friction modifiers, things that are going to throw that off, because you do need it to wear some. Sure. So some oils are too good, right? It's not going to wear in fast enough, and then you get oil consumption, you can get glazing and things like that because you don't have good oil control. So to me, I mentioned the brand, but the real key is you want that higher zinc, lower detergent, non-friction modified. That chemistry gets the job done.
Okay.
That's where we're going to use this piece too, right? When we get this thing ready, put together, and we finally get out the bins and the dyno, you guarantee that's what we're going to use to break it in, because we know it works. And you don't want a whole lot of oil getting in the combustion chamber when you're making big boost, because oil has a lower octane value than fuel, and detonation ain't your friend.
No, it isn't. Here to see where we're at. I can promise you, guys and girls, we're not playing with this style board gauge. Those bores are within a tenth of straightness. So now what we're going to do is Embry's going to switch over from that 170 grit diamond to a 600 grit cubic boron nitride, or CBN abrasive. We find that the CBN cuts very, very cleanly. There's no torn and fragmented metal like you'll find with a diamond abrasive. The diamond abrasives work very well. They're very long lasting. They're very economical as far as honing costs go, but they tend to tear and pull and plow, as we call it. So the bore has a lot of debris in it. If you were to look at it under a microscope, you'll see all of these. It's almost like a fuzz. And the CBNs clean all of that up. They're a very sharp abrasive. They cut very cleanly, and you get these beautiful valleys and peaks with the CBN abrasive. So that's one of the reasons we use it. It's also a super abrasive, lasts for a long time. Again, very economical from a honing cost or abrasive cost variable. Now what Embry's going to do is he's going to go into the plateau mode, and this is the really critical point of the operation. And what he's going to do is he goes in there, and we actually have a plateau mode on the machine. And typically what happens is when people are plateauing, the hone head is spinning, and you saw that in the other process when we were roughing. The hone head spins as it feeds the stones out. Well, when we're talking about microns, we can't afford for that hone head to spin 2 or 3 revolutions even while it's feeding the stones out. So in the plateau mode, the machine will feed the stones out without rotating at all. get to the right pressure, and then it begins the stroke and the rotation simultaneously. So we're creating a even plateau through the entire cylinder. In other words, we're not taking more peaks off of the top while the hone head is spinning, feeding the stones out. Very critical in the plateau mode to do it properly. So that's what we're going to try here. And what are we going to give the first one? 4 strokes, Embry, just to see if that's
I'm
where
going
we're
to
at?
set it 6, but we can change it to 4.
Let's change it to 4.
right.
Because we'd rather sneak up on it than
She's set to go.
all right. And what pressure are you going to run, Embry, on our plateau
We're
mode?
23%.
23% on the plateau mode. So,
And
All
we're
right.
at 100 RPMs on it also.
okay. So again, the hone head will not rotate during this process. It's feeding the abrasives out. You can hear it. It feeds them out several times and then begins the honing process. And what it does is it reaches the proper pressure and then it counts strokes. We're really not removing any material. You won't be able to measure the amount of material that's been removed. Again, we're talking microns, and our dial bore gauge measures in tenths. And one of the other things we want to do when we get down to this process is we want to make sure the bore is clean before we put our surface analyzer in there and take a reading. So we're going to blow it out. We're going to clean it out with some lint-free rags just to make sure. You can see how dirty that cylinder is. That's one of the reasons that we want to clean it out well before we take our final trace to know where we're at. Still got a little debris there, so we're going to switch again. All right. One more pass.
She's pretty clean.
And as we're looking at this, what it's doing is it's actually taking a trace of the surface finish. And just by looking at it, you can tell that we've got a nice plateau with the deep grooves. And typically, total seal will call for between 10 and 20 on the RPK. We have a 46 on the RK, and we have a 54 on the RVK, which is a little on the low side on the RVK, but still well within operating range. So that's how we typically do the plateau finishing. And again, just to elaborate a little bit when we're talking about the plateau finishes, if we would have taken that trace and our RVK would have been 95, we would have gone back in and taken a few more strokes with the 600 grit CBN, and that would have brought our RVK down. If our RVK is too light, then we maybe would have taken, we were taking 4 strokes here, maybe we would have taken 3 strokes, or we may have had to go into a rougher diamond in order to get that RVK number that we want. And materials will affect that RVK number also. A Dart block with a harder Brinell or a higher Brinell won't give you as deep of valleys as a stock Chevrolet block might, which is a much lower Brinell. That's why we're so animate about this. Isn't a one slice fits everything. You have to judge this. So that's why when we're in the roughing process, we always take that trace before we're to size to determine, geez, these 170, 200s aren't going to get her done, in this particular hardness. We might be a 140, 170 grit. And like Lake and I were talking earlier in this program, the diesel guys that are putting this unbelievable amount of boost in these motors, they're running an 80 grit in order to get the RVK numbers that they need.
The nice thing too is you have a selection of programs that you build yourself. So for say a boosted LS Dart, we always put LS Dart boosted, then we can put all the parameters in there as far as the strokes, the loads, the angles, and save it. So the next time we have one, instead of having it written on a notepad, thrown in someplace and you're digging for it, you just go to your program selection, click it and go. And if you want to modify it, then you modify it.
All right.
I'll let you be the control operator.
All right. But you can see that nice flat surface that the ring rides on, but yet you can see these nice deep valleys that's going to retain the oil. That's the key. Again, 14 RPK, 44 RK, and 48 RVK.
Okay, wow, Ed, Embry, that was a great job. Really cool. I love the tech detail. No skipping processes, right? Everything we did was documented to get to those finishes. And as a tribologist, right, piston, ring, and oil guy, like those numbers, feel really good about what we're going to do. So next video, when you see this engine, actually we'll be going together, this part of it, but Chris and those guys are going to be doing the cylinder heads and the valve train part, and it's going to be fun to see how much power
Can't wait.
this engine can really make, and then in the future it's going to be pretty cool. So thanks for watching.
I'm looking forward to that trip out there to Ben's place to dyno this beast.
Oh yeah, it's going to be great. Again, thanks for watching.
Yep, thank you.
Welcome back, Engine Performance Expo viewers. Lake Speed Jr. along with Embry and Ed. And we just finished this segment talking about engine blocks and things like that and how we hone. Well, I know, Embry, you've got some real world examples of what you've seen when you apply that technique. I mean, obviously, we went through a lot explaining in the video the different techniques of utilizing we'll call it the rougher grit abrasive to lay that foundation, and then coming back over it and plateauing. So, which I know that term plateau finish has been around for so long. I think what was nice about this video is we kind of didn't talk about it. We actually showed it.
Right.
Right.
Yeah, we did some experimenting with one of our customers on a process to do the 602, 604 crate engines, to keep them within spec, make them legal. And see the results, and the results we got back, real world results, dynamometer results, showed an improvement with that. And then we've worked with some asphalt companies. We've even worked with guys driving Subarus with turbochargers on them, and everything has been very, very positive. And you can't measure this stuff without having a profilometer.
Oh, exactly. And I think back to one of the segments we have videoed, we're going to show in January, visiting Drew at D&J,
right,
talking about the diesel stuff.
Yep.
I mean, share that story a little bit. I mean, not told the whole story, but tell a little bit about what he told us.
Right. So Drew was having problems, and obviously Keith, your counterpart at Total Seal,
right,
was trying to help him and trying to get him sealed up and make the rings last.
Right.
And we talked to Drew, and really it was strictly. We figured it out, or Keith figured it out.
Right.
We didn't. Keith figured it out that it was simply an RVK issue, that Drew couldn't get enough RVK in his cylinders to hold enough oil in there with how many, 60, 80, 90 pounds of boost that they were putting in.
An insane amount of boost,
5.9
a tremendous amount of fuel.
Oh, yeah.
So they had to have a ton of RVK to be able to even have a chance to lubricate the ring.
Yeah. Weren't able to get off the dyno originally, and after Keith worked with them for several times, not only did they not get off the dyno, they're now looking at the motor lasting an entire season without a freshen. So
they went from couldn't get off the dyno to making a couple hits down the track to run a whole season, never changed the ring, never changed the block material. They just changed the honing process.
All they did was change the honing process.
We did a boat motor for an individual. It was an older style boat, and he called me out to check out a few things. And one of the things that I asked him to do, I said, do compression tests through the whole motor. And he goes, I mean, I understand that you honed it, but and you bored it out a little bit. He goes, but I'm not expecting the cylinder pressures to be that high. They were 160 all the way around, and that was perfect for that. That was actually 15 more pounds than what it normally would do under factory specs. So he was right impressed with that, and I was too, to be truthful.
I think so. Yeah, exactly.
Yeah, absolutely. And that's part of this process is we can talk about this all day long.
Oh yeah.
Right.
Okay. But in the real world, we're seeing major gains in compression and ability to run a whole season without having a tear down or a freshen up or things like this, and I'm hearing that from not just you but an awful lot of customers that are amazed at the increase in horsepower that they're accomplishing with this different surface finish, and it's really not rocket science. It's
No.
This isn't any. I mean, you get so many of these guys that they have a secret soup.
Yep.
Right.
that they hone, or secret recipe that they hone these blocks by, and this is something that anyone can do. The machine and the process is very, very simple to do. Anyone can do it. You don't have to have 47 years of experience like I do. You can be a brand new honing person or operator and get the same results. So
we've even had other shops that questions the machine and have other equipment, and they do race quite a bit. And we had one gentleman that came in, we did nothing more than the same program that we do for others. He took it back, and of course I got tickled. He wouldn't tell us the dyno numbers, but he goes to the race and he's the #1 qualifier.
Yep.
He went from middle of the pack to #1, and all we did was just basically put the latest and greatest program on it and see what we could accomplish with it.
Well, it goes back to that there's power to be had there, which is we all are interested in that. But I think the other part some people kind of miss on is the durability. Back to the lubrication part, right? My love of life, right, is that if you've got that ring and that cylinder bore, it's not going to last if there's not enough oil. We always say, right oil, right place, right time, right amount. I mean, Joe's got it down earlier. He already knows it. So if you have proper lubrication, that part's going to live longer.
Yep.
And to me, that's kind of the whole goal, is that you can spend all the money and get the right parts, but if you don't have the right machine work, it's not going to last, and then you're just going to be upset because you spent a lot of money and you didn't get the results you're after. So having that proper lubrication and having the right type of oil, having it in the right place, right time, right amount, that's really the key to this, of what the honing process is. It's being those last three.
Right.
It's giving it a place to be, when it needs to be there, and most importantly, making enough of it there.
The right amount.
And back to the fuel thing, I think that's the key thing, is that RVK number really is going to be dictated by the volume of fuel you're running through the engine.
Right.
If you're running gasoline, you don't need as much RVK as you do if you're running methanol. If you're getting crazy diesel stuff, you're going to need even more than that. So it's just understanding that kind of roadmap to orient where you're going. And like I said, it's really easy now with the different abrasive options you have to be able to hit that number. A little bit of trial based on your machine and materials you're cutting and all that. Because there's going to be some tricks, right? I mean, a thinner cylinder is going to be a little trickier to mess with than a big cast iron block. But like you said, it's not rocket science.
Right.
To pull this off.
No, it's really not, and there are no big secrets.
No,
and it's become a much easier process, in my opinion. Embry, you've done it for years and years and years. You've seen the changes in the equipment and all of that. I mean,
to me it's amazing because one of the things we did back in the day when I comp raced was we always leaked the motor, and we would usually we design the motor, we develop the motor, and then we would leak it. And I found with this process we do now, we'll have almost 100% seal up, right off initial startup, compared to, 8 to 10%. So.
Right. And we're seeing that across the board. We're seeing that from a lot of people, that bringing this kind of technology and doing it this way, those are the kind of results you're getting. So, man, it's just, again, it's part of the advancement of the industry. Things are getting better. We're getting better life, better longevity, better performance out of it. And, obviously the technology and honing is part of it, but also part of that technology and engine performance is also cylinder head porting and things like that. So we've got a great segment coming up from the guys at Samtech. Judson and those guys are going to tell us a little bit how they use their race car to actually teach their students how to CNC program.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.